So if you watch the previous video, I showed you what the rotations are, but now we're going to have a look at specifically single rotations. A single rotation looks like this. There's only two cases when you're going to apply a single rotation. When your tree looks like this, or if it looks like this. Okay, like it looks like 1, 2, 3. Okay, that's just the nodes, or this is maybe, so you can see that imbalancing, if you apply the formula to every node, you're going to see imbalancing occurs here and imbalancing occurs here. So now this case on the left hand side is called the left case, because you can see all the nodes are going on the left, and because of the addition of this node, I get imbalancing occurring over here by the 5. Okay, so this is a left case. This is a right case. Okay, and to fix a left case, the way to do it is that you're going to take this node, right? You're gonna put it over here, okay, and you're gonna bring this on top. Okay, so this is called the rotation. So our resultant tree is gonna look like this after applying the rotation to fix a left case. This is how our tree is gonna look, resultant tree. Okay, now this tree is balanced. There's no imbalancing occurring. So this is an AVL tree, this isn't an AVL, this is a BST. Both of these are BSTs, but yeah, the point is that I've applied single rotation here, and I get the resultant to be that. Okay, so this is our final balanced tree for a left case. If I come over here to my right case, right, you're gonna do the same. You're gonna pull this one up. Let's do a different color. Red might be good. So you're gonna pull this middle node to the top, you're gonna pull this node to the bottom. Okay, basically make it the root. So you're gonna have something like that. Okay, now this is really a simple case, by the way, because sometimes what you find out is that when you do have RR or LL occurring, then let me give you an example. So yeah, the point is that the imbalancing isn't occurring yet, but the moment I add another node like 7, now imbalancing is definitely occurring. Now the question is, which type of imbalancing is this? Is it LL or RR? So it is right, because you can see by adding, if just let's go apply the formula. Okay, keep things simple. Okay, so left minus right will give us 0 here. Left minus right here is going to give us -1. Left minus right here is going to give us a 0. That's going to give us -2. So there's definitely imbalancing occurring at this node. And why? Because of the addition of that node. And this is right. So this is an RR case. Now I'm going to apply a single rotation, and the single rotation was the fact that actually not the fact that once you do apply a single rotation, your thing is going to look like this. You're going to take this node where the 5 is, right? You're going to take the 5, basically the direct child of the root node where imbalancing occurs. You're going to apply the single rotation. You're going to take the 5 to the top. You're going to take the 4 to the bottom. Alright, and it's going to look like this: 5 to the top, 4 to the bottom, and because 4's child was already a 3, alright, you're going to keep it like that. But now you see that 1's child was 1. 5's child was 1. Okay, so the left child, remember this is something people forget often. The left child of 5, okay, is gonna come to the 4. Okay, so you're gonna give 4 your left child, and this is going to be the same as is. Okay, and once you apply the formula to all of this, you're gonna see that this is balanced perfectly. Now the same with the the left case. Now imbalancing is occurring right over here because of the addition of the 1. Okay, so what you're gonna do is, this is an LL case. So you're gonna apply the single rotation again. So now let's just give 3 a bit of a child. Okay, I'm gonna make this, I don't know, maybe 3.5. Alright, like that. Remember, you cannot have 5 here because in the BST there's no duplicates. Inside of a tree you don't get duplicates. So now we have that. Now the next thing is that LL. Okay, this is LL. Now what you need is to apply the rotation. So once we apply the rotation, I'm going to use a different color for that. You're going to bring the 5 down, you're going to put the 3 up, so this is going to look like this. 3 goes to the top, okay, then 2 is going to be as is, 1 is going to be as is, but 5 is going to become 3's child, and because 3 had one child here, 3.5, this is going to become 5's child. Alright, and then this is going to be a 6, this is going to be a 7, this is going to be a 4. Alright, and this actually supposed to be a 1. Okay, so yeah, that's how it is. And if you apply the same formula here, you're gonna find out that imbalancing doesn't occur and this is actually balanced. So this is just something, full worst case scenario for a left case and a right case. Thanks for watching.